Hey, hi. In this video, we will see how to build an event-driven ETL pipeline with using AWS services like Amazon DynamoDB, which is acting as a source of data, AWS Lambda, which is acting as the major service which will help you to extract the data, transform the data, and finally load the data into the destination. So here we will use Amazon Redshift cluster as the destination here. So in total, we will have a source which is actually acting as a source of data, that is DynamoDB. So and then we will have the destination, that is Amazon Redshift cluster. This Amazon Redshift cluster will be fully secured and it will be deployed in the VPC. And within the same VPC, we're going to create an AWS Lambda. So that Lambda is acting as a kind of a resource which will actually extract the data and transform the data and finally load the data into the ETL with using the AWS provided backbone network through the VPS and VPC endpoint capabilities. So here we have the business a process where, for example, say order is been placed, that will create a record in the Amazon DynamoDB table, which will trigger the AWS Lambda through the Lambda triggered configuration that is using the DynamoDB streams. And then as soon as that Lambda gets triggered, which means that it will compile the code that we have written, a custom code which will actually does the multiple jobs. It includes like connection to the Amazon Redshift cluster, extracting the data from the stream, and then creating a dynamic query which will actually load the data into the Amazon Redshift cluster. While it is loading, you can also perform the required transformation of the data, right? So in total, this is very basic. I believe that it's very efficient event-driven ETL pipeline. So we will see how to construct this ETL pipeline in AWS account, and we will see a real-time demo in a few seconds from now. Let me first take you to the my AWS account, and then we will go from the from there actually. So this is my AWS account. So here I have created a DynamoDB table called face records, and if I explore this table, so it contains the schema something like this. So it has the schema which contains the face ID, email, name, phone book, and title, phone number and title, right? So this is the kind of a the table which actually stores the business record. So here we are mimicking order placement. So let's say that as soon as there is an order created, it will create a record in this DynamoDB table. Now this DynamoDB table becomes a source of triggering the AWS Lambda. So our AWS Lambda is kind of it's kind of a service which actually does the real-time data migration. That is, it actually receives the payload, it extracts the information from the payload, right? So here payload is nothing but that is a stream that is actually triggering the function, right? So this is the AWS function we have written for this particular demo, and there is a code which I will walk you through in a couple of seconds after a particular explanation here. So whenever there is a stream gets recorded, or whenever there is a record gets created in this DynamoDB table, so it will trigger this Lambda, and the Lambda does the actual ETL operation. So actually it is mimicking the scenario of event driven. There is an event happening in the process, in the business process, and in that one you are keeping a tool that is Amazon Lambda, basically AWS Lambda, which actually reads the record and then that transforms the data as you need. It will connect to the Amazon Redshift cluster or Redshift service, and then loads that data into the Amazon Redshift, where you can use that service for the data warehouse capabilities, which includes for training the machine learning models, getting insights with using the the other tools like say QuickSight and all. You can build the report like that, right? So this is basically so this is the pipeline which we're gonna see here now. What I do is as I showed you here, so basically let's go to the another the component that is destination here. Now we have seen this is the Lambda, and I'm going to walk you through the code in a couple of seconds from now. Let's first explore the Amazon Redshift Serverless. Okay, so basically I have created a serverless cluster. Now they have renamed, in the sense Amazon Redshift, now they are calling an instance into two components. One is namespace. So namespace is like a container. In that container, they're going to create an instance of Amazon Redshift Serverless. So that is, they call it as a work group, that is a test. So here our work group name is test WG, which is actually acting as a the SQL server. So here Amazon Redshift cluster looks to be built on MySQL. So that's the reason it is acting as the server. So let's click on a query data. So then we will see the actually the databases, server, and the tables here. Okay. So after this completion, I will go back to the code and I will walk you through the code, and then we will see the final demo of that. So here, when you click on a Redshift Query Editor version 2, which is basically query editor tool, it's an online query editor tool. So here it actually connects to the your SQL server, that is test WG, which is our work group, right? So we don't know what is the so basically it looks like they are using the MySQL in the backend, but for now let's go as it is. So this is our serverless work group, that is test work group. In that one, you see that there are built-in databases by default. So dev is the example database. You can actually clean this off and create your own databases as you need. For now, I'm using the built-in database called dev, and that has a schema called public, right? So as of now, it does not has any table. Now, for this demo purpose, I have created a query, that is SQL query, to create a table. Let me put that query here. So this is my query called, which actually creates a table in this particular schema, that is in the public. It contains face ID, email, name, phone, and title, which we have seen in the item. In the sense, the whatever the schema of this DynamoDB is there, I want to copy the data that is present in this DynamoDB schema into that table, right? So basically, we are migrating that the data present in the DynamoDB to Amazon Redshift cluster or Amazon Redshift Serverless. Now let's run this query and try to create a table here. When I write this, when I run this one from, so here I'm using the query editor. You can always use the your own tools to actually connect to this particular serverless Amazon Redshift. So here it looks like query went through, and if we refresh now, we should see the table that is created under the the dev database and public schema. So if I go ahead and try to see here, so we have a table now, and you can try to query this particular table like this. For example, say you can expand and try to go to this particular table, click on this one, say like select a table, right? And then you run the query. So basically you are running the the SQL command here. Currently it does not has anything here, right? So now I have shown you the setup here, right? That is, we have a DynamoDB table, we have the a tool, that is AWS Lambda, acting as a acting as a serverless capability, which is actually doing the 3 job: extract, transform, and load the data into the Amazon Redshift cluster. Now let's look at the logic that we have written, and then we can try to mimic the scenario, that is from when the order is placed, and that will actually act as an event, triggers the Lambda, and the Lambda loads the data into the Amazon Redshift cluster. Now let me take you to the code here. So I have copied this code in my VS Code. So this is the code. So anyways, you don't need to worry here. I'm going to share this code snippet in the video description. You can find it from there and try to use it from your side. All right. So first, let's walk you through the code, and then I'm going to go to the Lambda settings as well. So there are a lot of settings here as well. So here, what we are doing is we are using the certain Python modules. It includes OS. Then this is the you see that this is Python PostgreSQL module. Remember, this is a PostgreSQL, right? So that's the reason we used to see that Amazon serverless Redshift, right? So Redshift server cluster was actually mimicking the it is actually mimicking the PostgreSQL format, right? So that's the reason we need the Python PostgreSQL model. So I have installed this Python PostgreSQL model in my system, so I can show you that as well. So so basically, to install the this particular PostgreSQL model, you need to install the by this model. So let me show you that as well. So I have downloaded this particular PostgreSQL model. So let's show you that basically binary. So if you click on this one, so there is a pypy.org. If you go here, so there is something like this. So you go to this particular site and try to copy this one, and then you can always install the the utility, something like this. So if I here, I'm just opening it here as a admin, CMD as an admin, something like this. Okay, so then go and try to run this particular command, which will actually install the PostgreSQL module for Python in your system. So in my system, it is already installed, so it will not do anything. So what I do is so this is basically a prerequisite if you want to try to connect to the Amazon Redshift cluster. Okay, remember that in my case, in our case, the cluster is kept in a VPC, so it is not connectable. It is not, you cannot connect to this particular Amazon Redshift serverless from the laptop. Okay, so remember that to connect from your laptop, which means that you need to make this, Amazon Redshift public. Okay, now let's quickly go down. So this is the code. So basically, and here we're actually setting a certain variables that is needed to connect to the cluster, which includes database name, user, password, host, and port, like that. And this is the Lambda syntax, which has the Lambda function, that is Lambda handler function definition here. And here is the syntax of connecting to the Redshift serverless, right, which includes this model. So with using that model, we are calling a function that is connect, and it uses these many parameters that we have added as a variable, and those variables are using the Lambda OS environmental variable. I will show you where did I keep these parameters in the Lambda environmental variable, right? Since this is a Lambda function, so basically the value will be read from the environmental value, and these variables gets assigned with those values, and those so basically we are actually pointing those variables to the parameters of this function that is connect. Okay, so by virtue of this, basically with using these kind of parameters, the Python PostgreSQL module connects to the serverless cluster, and then you will have a connection that gets established. With using the connection, you are actually using a cursor. With using the cursor, you are actually performing the insert activity. So if there are any issues in the connection, so you will see this kind of errors. All right, so now let's go down. Since we are using the DynamoDB stream here, so what we are doing is, so we need to read the records from the each stream. So here stream is nothing but event driven. So we need to, so for example, say if DynamoDB table is invoking the Lambda in a batch of records, so we need to read the each records and try to create a format, transform the data, and actually load the data. So that is what we are doing it here. So we are actually only trying to insert the records into the Amazon Redshift cluster if it is an insert type event, right? But again, this property can be enhanced according to your need. And from there, we are actually extracting these many data from the DynamoDB stream, right? Which includes face ID, email, phone number, title, blah, blah, right? And then finally, you are constructing the insert query format. So this is something like PostgreSQL, the insert query format, which includes insert into, this is my table name. These are all the columns where I need to insert the values, and the values are in this format. So this is basically a single query, remember, like that. Yeah, and then so then again, here is the data. So with using this data, you see that, so data contains face ID, email, name. So what is the sequence that you have given here? That's the same tuple you are creating here. So if you see it, this is the tuple you are creating, and that tuple is been given as a parameter here to execute the query. So query here is insert into this particular table. So this is the cursor command which actually executes the insert query. If it is successful, it will not come inside the except block, or else it will go into except block and tries to throw the error. If everything goes good, then you are running a command called connection commit, which actually commits the changes. If everything is good, finally we are closing the connection. So closing the connection is very, very important. Okay, and finally, if it is successful, it returns that the data transform is successful. So this is the code we have written for this particular Lambda. Now let me go to the Lambda. So this is the code we have the dumped into this particular Lambda. And so since we are using the PostgreSQL module for Python, we need to create a Lambda layer. To create a Lambda layer, you can go to the Lambda layer here and try to create a Lambda layer for Python version 3.9. So don't worry, I have kept the the zip file through which you can create a Lambda layer. You download this particular the Lambda layer zip file, use it as it is. But here, remember that you need to use version 3.9 because this module supports only 3.9 runtime. So likewise, I have created this Lambda, and then so if I go to the Lambda inside this, so this is the basically module we have created, Lambda layer we have created, and then this Lambda layer is attached to the function that we have created, that is Lambda function here. So this Lambda layer which I have just now explained, so that is being attached here. Okay, now let's go to the little bit of configurations more, and then we can go for the further the demo of the scenario. So here we have set the general configurations to the timeout of 15 minutes, and then these are all the memory configuration which is needed. Okay, remember that. So this is basically performing an ETL operation Lambda. this Lambda has a certain capability. Remember that the payload data that it comes, it will particularly fit to the particular, the Lambda's capability. If you are putting the payload of more than like something like, say, 6 MB, something like that, then maybe it will not work. So basically, this is an event-driven ETL pipeline, and the payload information should be, minimum. There should be a particular threshold like that. So that threshold you can actually explore with AWS as well. And then we go to the trigger. So here I have added the DynamoDB as a trigger here. So if I open this particular show here, so how did we add? I can show you that as well. So click on a trigger and then go to the search for the Dynamo, and then here choose the, so for example, so let me choose the Terraform, so the another table for now, and then there is all the configuration that you can keep it as it is, and click on add, which will actually add a trigger something like this, right? So what does that mean is, in the sense, as soon as there is something, the record insertion happens in the DynamoDB table, it will trigger this Lambda. Okay, now let's go back to the diagram and now try to see the diagram, right? So which means that, so now we had the DynamoDB table, which is acting as the source of event, and then the event is listened by AWS Lambda, and Lambda has a logic which will actually transform the data and load the data into the Amazon Redshift cluster, and both are bound to a VPC. Let's see that configuration as well. So let me go to the VPC here. So if you see that this Lambda is being integrated in a VPC where the serverless Amazon Redshift cluster is sitting. So if I open this work group and go to its connections, or its network connections basically. So this is the VPC. So if I copy this is a VPC, this is a VPC ID endpoint. Then you have the, so let me open this into the another tab as well. Right, so now let me take you to the Lambda, which is basically sitting beside that particular tab. Let's copy this particular ID. I didn't copy it properly. Let me copy it again. Let me copy this ID, and we will show you that this is the VPC ID which we have integrated on the subnets. This is the security group, right? And then it has the inbound and outbound. If you see here, I have allowed all internet access, but that is not required because it will use the AWS backbone network and try to connect it here. Okay, and then we go to the DynamoDB. So here, if you see that public access is blocked, which means that the traffic is not going through the internet. It is going through the AWS backbone network, which is very secure mode to communicate your cluster, right? And then I was showing you on the VPCs. This is our VPC, right? And it contains the subnets. I've created 3 subnets because Amazon Redshift Serverless demands to you have 3 subnets. And then one more thing is basically, make sure that you distribute those subnets into multiple AGs for high availability purpose. Then you have a route table configured, then an internet gateway is attached. All right, so that is the basically, the setup of the, Lambda and Amazon Redshift cluster into this particular VPC. And one more thing on the VPC is on the environmental variable. So I have set the environmental variable. If you see here, so we have a host name. So the host name is nothing but your Redshift server endpoint. So that Redshift server endpoint, you can find it from here. So that is something like, if you go to the your work group in the general information, so there you will see that server name. So if you go to the ODBC URL, the server value is actually acting as your host name, and this is a database like that. Yeah, so that information is being kept in the Lambda environmental variable. Then it has the password, which is the password which you will create during the Amazon Redshift serverless creation per time, right? Then the port number is, remember the port number here is 5439, and then the username is basically admin, which is default username. And so this is how I have set up this particular pipeline. Now time has come, right? So let's try to mimic the scenario. Let's say there is an order placed in. So what does that mean? In the sense, there is a record inserted into this, the particular VPC, into this particular DynamoDB, right? And then gets loaded into the Amazon Redshift DynamoDB table, right? Let's show you that. So if I go to this query, so for now, this table is empty. Now let's try to add a record here. So let me copy this particular record, and I will go back to the, this particular table, that is face record. And I'm going to create a record now. We'll go to the JSON view and then do like this. So let me try to create a face ID with the something like this. Okay. So let's say the face ID is 100, and these are all the data informations. Okay. Now let's create a record. So I'm creating a record now. So it says that, the additional record, basically, this primary key is already exists. So in the sense, my table already has this ID. That's the reason it's throwing. So let me make it as a little bit bigger. So I'm creating a record because the face ID is basically primary key in this table. So that's the reason it was throwing the error. Now let's create this record yeah. So let me create the record now. So we have created the record successfully. This should trigger the Lambda. Let's go to the Lambda's monitoring option and click on View CloudWatch Logs. Here you should see the log group getting created. There should be a log there around the current time, right? So if I open this one, we should see the logs as of now. Looks like went good, and we try to run a query again, and let's see if the record got inserted here, right? I'm just refreshing it. Here you go, right? So we have inserted a face ID with a value equal to 10,000, and these are all the other information. It got loaded, right? And then I will keep on doing to the next value as well. Let's create another few more records, right? So and then we will see that it's get loaded. So let me just change the value and try to create a the item here, right? I will keep creating couple of times. So I created one. This is the basically third record that I'm creating, right? And then again I will create a one more record. This is basically fourth, right? And then yeah, this is 3. So now I have created 3 records. Let's see that whether those records got inserted into the Amazon Redshift Serverless. Here you go, the records are got inserted. So not only the record getting here. So now if you go to the diagram and try to see that, so basically there's a business process which is creating a record in the DynamoDB table, which is a NoSQL one, and that triggers the AWS Lambda, which is actually acting as the ETL pipeline to load the data from this DynamoDB stream into the Amazon Redshift cluster, right? So I'm from the Amazon Redshift cluster, which means that your data warehouse is now set. With using the data warehouse capability, you can have the enterprise grade the applications of Amazon Redshift data warehouse services, which includes you can use that data for machine learning purpose, have the visual intelligence purpose, right? Or basically data analytics purpose. You can use it for the reporting purpose or any other use cases of data warehouse capability now achieved with this setup. All right, so finally let me conclude this particular demo. So finally, a kind request, please do subscribe my channel. That would really encourage me a lot. With that note, thank you, thanks a lot, and see you in the next video.